Ice creams you eat? 5 ice creams? 10 ice creams? Okay. Which means you're not going to share this with anybody. You're going to take the whole of the ice cream. This is what you call as integers. Right? But to know more about integers, let us start with a small example. I'll be covering around some 8 to 10 terms in today's session. First, if I draw a few circles, okay, I'm taking a few circles here and I ask you to count the number of circles. I ask you to start from here. How you start the counting? 1, 2, 3, 4, 5. This is the 6th circle, 7, 8, 9 and 10. So how many circles you have? You say it's 10 circles, right? With what number did you start your counting? You started with 1. 1, 2, 3, so on. This is what you call as the counting numbers or natural numbers. Counting numbers or natural numbers. If you start with 0, that is 0, 1, 2, 3, etc., 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 that goes on, there is a no stop, you call this as whole numbers. Is it okay? You call this as whole numbers. Probably you know this number line, right? I take a number line. So this will be going on and on and on. Let me take this number to be 0, this number to be 1, this number to be 2, this is 3, this is 4, this is 5 and so on. And what will be lying to the left side of 0? Minus 1? Yes, right. Minus 2, minus 3, minus 4 and so on. So this side, left side is all negative values and right side is all positive values. If you start from 1 and all the values lying to the right side, it's what you call as natural numbers or counting numbers. You know this, right? Natural numbers, or the other name for natural numbers is counting numbers. With this 1, 2, 3, etc., if you take also 0 with this, you call this as whole numbers. What's the difference between natural numbers and whole numbers? Only this 0 is the one value where it will be included in whole numbers. Is it okay? So this is the set of natural numbers, and if you include 0 along with the natural numbers, it's the set of whole numbers. Is it okay? So whole numbers and natural numbers are all positive. If you shift to the left side of the number line, it's all you get negative values. The negative values, 0 and positive, all the three set is put together what you call as integers. This is what you call as integers. Is it okay? So what are the different types of integers? You know what is integer? No sharing number. It's a whole number. You take a 3, which means what? It's a 3 whole number. 3 whole number, right? So what are the different integers you know now? Yes, what are the different integers you know now? Yes, please join with me. You know a positive integer. Can you give an example for a positive integer? How many ice creams did you eat? 5 ice creams. 5 is a positive integer. You have a 0. You have a negative integer, minus 2. That's lying to the left side of the 0. And apart from this, you have 2 more special integers. It's not special integer, it's a special variation which is called as non-negative and not positive. Non-negative and not positive. Non-positive. How can you call this 0 is? This 0 is neither positive nor negative. You agree with me? neither positive nor negative. Let me extend the case. Again, I am going to draw a number line. Okay. Again, I am going to draw a number line where this extends to infinite side, to the right hand side, and this extends to the left hand side, goes on and on and on. So to the right hand side here lies the positive values, positive integers. To the left hand side here lies the negative values called as negative integers. So what is this one called as? Yes, please join with me. What is this one called as? Positive integers. Is it okay? We use the symbol positive plus and d. And what is this? These values starting from 1, it is called as negative integers. Good. Negative integers. So I represent using a minus sign, then B and E for negative. This 0 is a special case where it is neither negative nor positive. Neither negative nor positive. Okay, fine. Okay. Now, this side is negative, right? See here. This side is all negative, right? Which is non-negative? Which is non-negative? Non-negative. See, I use the term non-negative, which means not negative. Am I right? Not negative, which means starting from 0 and all the numbers lying to the right side is called as non-negative integers. Is it clear? What do you mean by non-negative? Not negative. What are the negative values you know? -1, -2, -3, etc. Then not negative means you have to shift from this -1. So it starts from 0, 1, 2, etc. is all non-negative. And I can include non-positive, but it's a very rare case we use this term non-positive. So you can guess which is all non-positive. Which is all non-positive. Over here, and all the values lying to the left hand side is called as non-positive. Is it okay? Is it clear? Fine. So what are the things we have seen so far? Let me summarize. What are the things we have seen so far? Yes, please join with me. We have seen natural numbers, or what's the other name for natural numbers? Counting numbers. Very good. And we have seen whole numbers. Is it okay? That is starting from 0, 1, 2, etc. And we were discussing integers. What do you mean by integers? In short form, no sharing number, which is you will not share your ice cream with anybody. And we were discussing with respect to types of integers. What are the types of integers? It can be a positive integer. It can be a negative integer. Okay. It can be a 0 value. It can be non-negative and also non-positive. Is it okay? Non-positive. And can you tell me, or shall I write these integers as a complete number? You agree with me? What is this integer? A complete number. Okay. If I give you a cake, okay, will you share with me? No, you're not going to share with me. Very bad. You're not going to share with me. I know you're a good girl, but when you eat the cake, definitely you will share with me. Then we'll take into equal halves. This is for you and this is for me. Which means what? This one cake is divided between two persons, which becomes a sharing number. Then this is not an integer. It is called as a fraction. So we are introducing a new term, which is a fraction. And this fraction, which is sharing, or is not a complete number. Not a complete number. Is it okay? Can we go for the types of fractions you know? What are the types of fractions you know? Proper fraction, improper fraction, and mixed fraction. For example, proper fraction is what we have done here, 1 by 2. In case there are 3 cakes, okay, and these 3 cakes are to be shared between 5 people, which is 3 by 5. Am I right? How many whole cakes are here? 3 whole cakes are here. So let me use this side of the board for you. So how many cakes are here? 1 cake, 2 cake, and 3 cakes. How many cakes in total? 3 cakes in total. How many persons are going to share these 3 cakes? 5 persons, which means you write this as 3 by 5. At any time you have gone with your parents to a restaurant and you have taken any vegetable soup or non-vegetable soup, chicken pepper soup or tomato soup or mushroom soup, usually they will order 2 by 4 or 1 by 2 or 2 by 3. Have you ever noticed what is this 2 by 4, 1 by 2 and 2 by 3? What is this 1 by 2? What is there in the numerator? It's 1 divided by 2. That is 1 soup. It will be shared by 2 persons. Is it okay? This is what you call as a fraction, and here numerator is a number less than denominator. 1 soup with 2 persons. You call this as proper fraction. Okay? Instead, I am going to share these 3 cakes with 2 persons. You understand? I am buying 3 cakes. One is butterscotch, okay? One is chocolate, and another one is strawberry cake. Okay. You like butterscotch, I like strawberry very much, and this chocolate cake, we both like it. So you are going to take whole of butterscotch, I will take whole of strawberry, and this chocolate will be divided, right? Which means these 3 cakes will be divided by 2 persons. Is it okay? What is this 3 by 2? 3 cakes divided by 2 persons, which means you will get more than 1 cake. Am I right? How many cakes you will get? 1 full cake and 1 half a cake. So here the numerator is greater than denominator. Yes, what's the numerator? 3. What's the denominator? 2. It's greater. But in the other case, what we have seen, 1 soup, that is 1 numerator, denominator 2 persons 2, so 1 was less than 2. It's what is a proper fraction. Is it okay? The next case, in the second case, where the denominator is less than, that is numerator is greater than denominator, is called as improper fraction. Is it okay? Improper fraction. In case, if I take this way, please note here, there are 11 cakes and is to be shared between 3 persons. Okay, 11 cakes to 3 persons. How you do this? Shall we go the long division method? 11, 3, 3 3s are 9, remainder 2. You know the QRD rule? What is the divisor here? 3. So, here 3, right? Here 3. What's the quotient? 3. And what the remainder? 2. Right? Am I right? 3, 2 by 3. So, this 11 cakes has to be shared between 3 persons. We get this in QRD rule. That is 3, 2 by 3. 3, 2 by 3 is Not like a proper fraction, not like an improper fraction. This is called as mixed fraction. So here I have 11 cakes to be shared between 3 persons. Here also looks like numerator is greater than denominator, but how I present this? In the form of QRD. Okay, QRD rule. QRD. Here I call this as mixed fraction. So how many fractions we have seen? Proper fraction, improper fraction and mixed fraction. Is it okay? So let me finish it off summarizing here. So we were summarizing this one, right? So I am going to include, I have included here mixed fraction, right? Improper and proper fraction. Hope it is clear? Good. Next I am going to discuss on multiplication and division of integers. So you know what is an integer now? Shall I say that integer is not a fraction? Integer is complete thing you're going to have. Fraction means sharing. Integer and fraction are not same, right? Fine. I'm going to discuss on multiplication and division of integers. Multiplication and division of integers. Okay. Simple. Minus 2 into minus 2. What's the value? Please make it faster. You have 2. You have 2. 2 into 2, 4. It's a negative sign. Here is a negative sign, which means it becomes positive. I take 2 into 2, which means what? Here is positive 2 and here is positive 2. What happens here? 2 into 2 is 4. Both the signs are positive, so positive. Yes, we know this. If I take 2, that is positive 2 and negative 2. So 2 into 2 is again 4 and you have plus and you have a minus. So you'll get minus 4. Here, if I take minus 2 into plus 2. 2 into 2 is 4. Okay. Minus plus, which is negative. In short, I shall write this as I take this one negative integer, okay, into another negative integer. What sign I get? What I'll get here? Equal to positive value, right? Positive integer. What sign I get? Positive sign. What integer I get? Positive integer. Here, what is here? Positive value. That is positive sign. And here, into positive sign. What I'll get here? Positive value. What do you understand from this? If both the signs are same, then the value will be then the value will have a positive sign. Both the signs are same, then the value will be positive sign. The next set here, positive value into negative value. What do you get here? Negative value. This minus 4, right? Negative value. Here, negative value into positive value. What do you get here? Negative value. So, shall I say that one positive, one negative, one negative, one positive. If you multiply two different integers or two different signs, you get a negative sign. So, here you are concluding with the positive sign and here you are concluding with a negative sign. The same happens when you divide also. Can you please check? See, instead of multiplication you divide it. Okay, you will get a positive 1, right? What is minus 2 divided by minus 2? It's plus 1. What is plus 2 divided by plus 2? It's plus 1. Okay. What is plus 2 divided by minus 2? It's minus 1. What is minus 2 divided by a plus 2? Which is minus 1. So, instead of multiplication, if you take division also, with respect to the signs, it will be both the signs same means you'll get a positive value. Both the signs different means you'll get a negative value. Is it okay? Yes, that's it. Over. With respect to multiplication and division of integers. One more point. If I multiply here, please make a note. If I multiply here, I take negative sign, one more negative sign, and one more negative sign. Okay. What sign I get here?
Minus.
Okay, negative sign. I take negative sign, another negative sign, another negative sign, and one more negative sign. That is 4 times I take negative sign.
Yes.
Positive sign. So, shall I say that here is a pair is positive. Here is a pair, it's positive. So, positive. Here is a pair, positive. But there is no pair for this one. So, positive into negative is negative. So, here no pair means what? Negative. Here we can pair it. So, positive. Is it clear? So, that's all on multiplication and division of integers. So simple. Next, I am going to discuss one small thing with respect to what happens if we divide by 0. What happens if we divide by 0? Or there is, I have numerator by denominator form. Okay, I take 0 by C. What is 0? No kicks. Okay, what is 0? Numerator, no kicks. No kicks. Denominator, 5 persons. How many cakes a person will get? 0 cakes, because no cakes at all. Is it okay? So 0 by C. C is any number, means it will be 0 only. But you have to make sure that C is not equal to 0. Is it okay? C should not be a negative C should not be a negative 0 number. Okay. Second case, the same denominator, numerator by denominator form, but C by 0, which means 5 cakes and 0 persons. The shopkeeper has baked full of cakes, all fresh creamy cakes, but no persons coming there. What will happen? You cannot define the business. It's not defined. Is it okay? It's not defined. So here C by 0 means you cannot define it. The person, the baker has to wait from the morning till the night, and he has to wait and see whether any persons will be coming. So it's not defined. How you say this number? If you are dividing by 0, you call it as not defined. If 0 by C means the value is 0. Is it okay? Fine. The tables from 1 to 10. So this I have on the board for you. We are going to introduce a few terms. For example, if I ask you with the number 20, can you find where are the number 20 here? So can you find it over here? Can you find it over here? Can you find it over here? Where else? I think that's it here. Only in these places you can find 20, right? So shall I write this 20 in the first case here? 2 into 10 is 20. In this case, 20 is 4 into 5, right? In this case, 20 is 5 into 4. And in this case, 20 is 10 into 2. And probably you can find it in 20 tables also. 20 is 1 into 20. And also 20 into 1 is all same. Only in these places you get 20, right? See, if you make a note, this 20 can be split with respect to 2, with respect to 10, with respect to 4, 5, 5, 4, 10, 2, 1, 20, 20 and 1. This is what you call as factors. This is what you call as factors. So, what are the factors of 20? 2, okay, 2, 10, right, 10, 4, right, 5, 1 and 20, okay. So, if I go in order, 1, 2, 4, 5, 10, 20. These are the values, or these are called as factors of 20. What do you call this? Factors of 20. It's quite simple. Let me take one simple example. How can you take, what are the factors of 6? 1 into 6 is 6. 3 into 2 is 6. 2 into 3 is 6. And 6 into 1 is 6. Right? So, what are the factors of 6 you know? 1, 2, 3, 4 or 5? No, 6. Which means with the help of 6, you can multiply by 1 and you can get 6. With the help of 2, we can multiply by 3 and you can get 6. Likewise, you call these 4 values as called as factors of 6. Is it okay? You call this as factors of 6. Let me tell you a small story. Are you ready to listen to the story? Yes, tell me. There lived two persons in the forest. There lived two persons, X and Y, in a forest. Okay. Do you know who is this X and Y? Mother and daughter. Okay. It's a cutie story. Mother and daughter. Who is the mother? X. Who is the daughter? Y. Okay. I am going to make two lines here. First line. X is the mother of Y. Am I right? Second one. Y is the daughter of X. No laughing. Both are same lines, but in two different angles. You agree with me? First, I am focusing X. Who is X? Mother of Y. In second line, I am focusing Y. Who is Y? Daughter of X. The same way, if I talk about 6, which is 3 into 2, I shall write 3 and 2 are factors of 6. Okay. Also, I can write 6 is a multiple of 2 and 3. Able to get my point? Do you understand this cutie story? What is this cutie story? Once upon a time, there lived two persons, X and Y, in a forest. X is the mother and Y is the daughter. So we have framed two beautiful lines here. What's the first line? X is the mother of Y. What's the second line? Y is the daughter of X. Altogether, there are two persons in the forest. Right? Likewise, I have taken 6 is equal to 3 into 2. See, the way I express is different. If I want to talk about this 3 and 2, I say, how do I express this 3 and 2? If I want to express this 3 and 2, how I express this 3 and 2? 3 and 2 are factors of 6. Is it okay? 3 and 2 are factors of 6. As I was focusing here, how was I focusing here? X is the mother of Y. Likewise, 3 and 2 are factors of 6. In the second line, I was focusing Y, right? Y is the daughter of X. Likewise, I can say that 6 is a multiple of 2 and 3. Is it right? You agree with me? So what are factors? How can you break this 6 into 3 into 2? I call this as factors. Okay. How do you call this factors? Because 3 into 2 is 6 and 2 into 3 is 6. So 6 is a multiple of 2 and 3. It's the same thing you are expressing in a different angle. X is the mother of Y, Y is the daughter of X. This is the same thing, but you are expressing in a different way, right? See, in the tables, in the multiplication tables here, if I ask you this one, what is this one? 9 into 1 is equal to 9. Express in two lines, one with respect to factor line and one with respect to, yes, please. So I am asking you to express 9 into 1 is equal to 9 in terms of factors first. 9 and 1 are factors of 9. Is it right? If I say the other way with respect to multiple, how can I express? 9 is a multiple of 1. Is it right? Is it right? Shall I give one more example? Or which one I can take? Shall I take this one? 8 into 3 is 24. Shall I take 8 into 3 is 24? Yes, can you help me out? Please join. 8 into 3 is 24. First way of expression. 8 and 3 are factors of 24. Second way of expression, 24 is a multiple of 8 and 3 or 3 and 8. Simple. Do you know where are the multiples of 3 and 8? What are the other multiples of 3 and 8? If there is a word multiple of, it's very simple. Go for the multiplication table. Go for the multiplication table of both 3 and 8. All the values. See, this is the third table, right? This is the third table. This is the third table. Take all the table. Let me take one more page. You take this, you take the 6 tables, okay? 6, right? Tell only the answers. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. These are all multiples of 6. Okay, multiples of 6. Can you tell the multiples of 10? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. These are all multiples of 10. So multiples means what? You have to bring all the multiplication table. It's very simple. It's only up to 100 you have. You can go 110, 120, 130 and so on. These are all multiples of 10. Is it okay? These are all multiples of 10. In the case multiples of 6 and multiples of 10, which is the factor that is very common? Very common factor.
30 and 60.
Yes, thank you. 30, here is also 30. 60, here is also 60, right? I'm not going to worry about this one. I'm going to take up to 100. So here is 30, okay, and 60. These are called as common multiple. These are called as common multiple. In this common multiple, if I take the least value, what's the least value here? 30 is the least value. This is called as least common multiple. Do you know LCM? Yes, we have found the LCM. What is LCM? L stands for least, lowest or least. C stands for common, and M stands for multiple. You call this as least common multiple or lowest common multiple. Okay? How you find this? You have to go in reverse order. What's the first step of finding this? Find the multiples. Did you find the multiples of 6? Did you find the multiples of 10? Fine. Find the common multiple. What's a common multiple? 30 and 60. Okay. So these two are the common multiples. And what is LCM? You have to find the lowest value, least value. Which is the least value? 30. This is called as least common multiple. Is it okay? This is called as least common multiple. On the other way, if I take factors of 6. What are the factors of 6? 3 and 2. Am I right? And I take factors of 15. 3 and 5. What are the common factors here? What are the common factors here? 3. Good. If I tell 30. Okay, sorry. 1 second. If I take another set 2, which is factor with respect to factors with respect to 6 and 30. What are the factors of 6? 3 into 2. What are the factors of 30? 2 into 3 into 15. Sorry, not 2 into 3. Into 5. Am I right? These are the factors of 30. Is it okay? These are the factors of 30. Now, what's a common factor here? What is the common factor here? 3 and 2. Yes. What is the common factor here? 2 and 3. What's the highest common factor here? Highest common factor here is 3. If there is only one common factor, there is no comparison. You find two common factors here. You go for the highest common factor, which is 3. This is what you call as HCF. Okay? H, C and F. So what are the things we have seen now? Can you summarize please? We started with what do you mean by factors? What do you mean by multiples? Okay? Least common multiple. Least common multiple we have discussed, or highest common factor we have discussed, right? And also we had a Kuti story. What's a Kuti story? Mother-daughter story. So we have differentiated between, so one factor, two multiple, third least common multiple, that is LCM in short, fourth highest common factor, that is HCF in short, and we were differentiating factor and multiple with the help of What? The goody story, right? So we have done this fifth one. And one more thing with respect to prime numbers. Do you know what is a prime number? For example, if I take 7, what are the factors of 7? It's only 1 into 7. If I take 6, what are the factors of 6? 3 into 2, right? I can write as 1 into 6 also. 3 and 2 are factors. See, prime number is something which has only 1 and the same number as factors. So for 7, 1 and the same number 7 as factors. If I take 11, what are the factors of 11? 1 into 11 is 11. So 1 and 11 are the only factors. So you call 11 as the prime number. Is it okay? You call 11 as the prime number. That's it. Only two factors. 1 and 11 are the prime number. So with respect to prime number, what are the factors? That 1 and the same number will be the factors. This is what you call as prime numbers. And if you talk special about 1, 1 is nothing but 1 into 1. So you cannot call neither prime nor composite. What is composite? Not a prime number. What is composite number? Not a prime number. What is a prime number? Has only two factors. What is a prime number? Has only two factors. What are the two factors? 1 and same number itself. What is a composite number? Not a prime number. Is it okay? Not a prime number. What is this about special 1? It's neither prime nor composite. Neither prime nor composite. Okay, that's all. So overall we have gone for so many number of terms we have learned today. First one, natural numbers. Second one, whole numbers. Third one, integers. What are the integers we have done? Positive, negative, 0, non-negative, non-negative, non-negative and non-positive integers. Actually, we will not use this word. It's very rare only. We will not use it. Then fourth one, we are discussing with respect to fraction. What is an integer number? It's a complete number or no sharing case. Right? What is a fraction? It's a sharing number. And what are the different types of fractions we have seen? Proper fraction, improper fraction and mixed fraction. Is it okay? Proper, improper and mixed fraction. And we were discussing with respect to symbols. Right? Even into even, sorry, minus into minus, plus. So we were discussing with respect to signs with respect to multiplication and division of integers. Okay. Then we were discussing with respect to multiples. Okay. Factors. Yes. LCM, HCF, and we were discussing the difference between factors and multiples. Is it okay? And we were discussing with respect to prime number and composite number. That's all for today. Thank you.